The present day CAN bus system was mandated in 2008. If you're working with vehicles that were built prior to that, you're looking at the J1850 protocol. That came in two flavors. Ford had the two-wire PWM, pulse width modulated. GM had a single wire. So I have two vehicles here today of that vintage. This 2001 GMC Wrangler and my own 2002 F-150. So this will be a short tutorial on how to capture each one of those waveforms and what to look for within them. Most automotive oscilloscope work is of a very low frequency nature. Scoping communication networks ranks up there in demand for budget oscilloscopes that we promote here. That's why I thought that this would be a very good test for the HS102 that we built in Gadget 62. It's the scope that we're going to use today. The General Motors version of J1850, the variable pulse width, is a single wire system. So we're on pin number 2 to ground, channel 1 on the oscilloscope, taken at 900 kilosamples per second, picture perfect waveform. It's a 0 to 7 volt, which most budget oscilloscopes are in the plus and minus 5 volt input range. So our little HS102 with the plus and minus 15 volt is pretty well suited for this work here. We don't look to decode any of these networks, whether it's the modern day CAN bus, the J1850 that came before it. As troubleshooters, do-it-yourselfers, I think professional mechanics, we're interested in the waveform, the integrity of the waveform. We are looking for the pulse width here. 64 nanoseconds for the narrow, 128 nanoseconds for the wide. It's going to be a sequence of those. And here I've slowed it down to 450 kilosamples per second, and it's scoping mode on the fly. We're just looking to make sure that it stays between the 0 and 7 volts and that it has the proper profile. That's a clean waveform. That's what a good waveform looks like. Let's move on to Ford's version of the J1850. The PWM version of J1850 that Ford was using was a two-wire system. Bus positive on pin number 2, bus negative on pin number 10. I think it's a much more robust system. It's certainly a faster system. It has 4 times the transfer rate of the GM variable pulse width system, which was at 10 kilobits per second, and this system here can go 40 kilobits per second. Faster network means a little more challenging to capture. This was done at 2 megasamples per second, and the HS102 rose to the occasion. And the faster transfer rate of the Ford pulse width modulation means that the width of the pulses are much more narrow. Here, they're as narrow as 8 nanoseconds, where with the GM version, the most narrow was 64 nanoseconds. It's also known as a differential system. So when the bus positive is at 5 volts, the bus negative is at 0. When it's at 4, the other one is at 1, 3 is at 2. They must add up to 5. So I'm going to show you something here. H-scope has full math capabilities. Let's select that, and let's choose channel 1 plus channel 2. So that red line that you see near the 5 volt thing, if that ever dropped out, that would tell you that one of the 2 channels caused this not to add up to 5 volts. So I think our little HS102 that we built in Gadget 62 was able to rise to the occasion. Nothing wrong with these waveforms. And I hope that this short tutorial on the J1850, both flavors of it, was useful. Talk to you guys soon.